Hello everyone and welcome to week 4 of Poll 361. This week we will discuss the importance of measurement when beginning the research process. Once you've identified the main concepts of your research paper, the next step is determining how to measure or operationalize those concepts. In the first part of this lecture, we'll run through some examples of how to operationalize variables. Another critical factor is making sure that your measurements are accurate, or in other words, does a specific way of operationalizing a variable actually measure what you intend for it to measure. And finally, we will review the terminology used to describe different types of measurement and demonstrate how more precise levels of measurement influence the extent to which we can make inferences on the relationship between the variables or concepts. First, let's begin with a proper definition on operationalization. So, operationalization, a very fun word to say, is the process of measuring the presence, absence, or amount of a given concept. In other words, operationalization is the process of deciding how we will record our empirical observations. In the data and methods section of your research papers, you will explain or justify why you chose a specific operationalization for your given concept. This is referred to as an operational definition, which often includes an empirical threshold for the concept that you are studying. So let's go over some examples. First, assume that our research question is, do literacy rates affect how democratic a country is? So very much like we did last week, the first things that we need to do are break down the concepts present in the question. So here, obviously, we're talking about literacy rates and democracy. Looking at this specific word here, affect, we can see that the independent variable is literacy rates because we are expecting that to have an effect on our dependent variable, how democratic a country is. So one potential hypothesis might be countries with higher literacy rates will be more democratic. They're more educated, thus more likely to participate in politics and make informed democratic decisions. So how do we operationalize literacy rates and democracy? As we discussed in the Week 3 Part 3 lecture video, different types of measurement can lead to very different results. So let's examine two potential measurements or operationalizations of literacy rates. So say you've been reading through the literature and you've noticed that studies generally measure literacy rates in one of two ways. First, you find that some studies measure the percentage of the population with a high school diploma. We use this as a proxy for whether or not someone can read. And like we've discussed through most of the lectures up until this point, data is not always available for the specific concepts that we want to study. We can't simply institute a global survey of every single person living on Earth and ask them to perform a reading comprehension survey for us. The data simply does not exist. But we can assume, and a lot of data analysis relies on assumptions, but we can assume that if an individual does have a high school diploma, that there is a high probability that they are also literate. So out of the 12 random countries that we sampled in our fake research paper here, we see that countries A, B, C, and G, H, I have at least 50% of the population obtaining high school diplomas. On the other hand, perhaps that we've noticed that some studies measure literacy rates on a different set of criteria. In this case, does at least 50% of the population have at least 6 years of formal education or not? And when we use this operationalization, we see that countries G, H, and I no longer meet the criteria, and instead countries A, B, C, and D, E, F meet the criteria of literacy rates. So as you can see from this example here, it's important to consider which measurement most accurately reflects the concept that you're trying to study, because some measurements may exclude cases that otherwise possess the characteristics that you're really interested in studying. The same is applicable to how we measure democracy in a country. We could measure how democratic a country is by examining whether officials are elected in competitive elections or whether or not all citizens have the right to vote in a given election. And just the same, we see that certain levels of measurement might exclude cases that otherwise possess the characteristics that we're really interested in studying. For example, If we use the operational definition of democracy as all citizens can vote, then we see that that includes countries D, E, F, and A, B, C. On the other hand, if we thought whether or not elections are competitive is the best measure of democracy, that drastically changes our selection of cases. So even though every citizen can vote in countries A, B, and C, they do not have competitive elections. So according to that measurement, countries A, B, and C are not classified as democracies, even though they generally meet the textbook definition of a democracy. So when choosing how you will measure or operationalize a specific concept, one thing that you really want to consider is, one, does that measurement capture how the concept should be or how it actually is? And two, is the measurement too broad or too restrictive? For our democracy measurements, the operational definition of elected in a competitive election is problematic for a couple of reasons. Even in the United States, we know that there are plenty of state-level elections that are not competitive, and many candidates often run unopposed at high levels of office. So does this mean that the United States is not a democracy? Well, of course not. Instead, this is really just a normative expectation of what democracies should look like. It makes sense that democracies should have more competitive elections, but again, that's a normative statement. Empirical evidence shows us that this is not a defining, universal characteristic of democracies. Voting rights, on the other hand, is a far more universal and defining characteristic of democracies, and thus it's a better operationalization in general. In the case of literacy rates, we can ask ourselves, is one measure more restrictive than the other? Or could one of these measurements theoretically encompass the other? And in this case, it makes sense to assume that if an individual has a high school diploma, it's highly probable that they also have at least 6 years of formal education. So in this case, high school diploma is probably the best operationalization of literacy rates. And so just to do a quick recap of how the operationalization process goes, yeah, I told you it's a very fun word to say. We begin by identifying the concepts in the research question. So that was literacy rates as our independent variable and democracy as our dependent variable. Step 2, we need to define those concepts. So after thinking through all of the potential measurements that we could possibly use and weighing the advantages and disadvantages of each, thinking about whether they are normative or restrictive definitions, we determined that high school diplomas and voting rights are the best operational definitions for our concepts. And then finally, we operationalize those definitions. We collect data from population surveys in each country, and we then determine the percentage of individuals in each country with a high school diploma. And then we determine whether or not all citizens have the right to vote in elections in each country. Okay, so that is the essential process of how to operationalize concepts. Let's do a couple more examples to really understand the process of operationalization. So say we wanted to analyze whether children grow faster if they eat more vegetables. Just like we did in class last week with the homework journal, we first begin by asking ourselves, what are the concepts? So we see children, we see growth, and we see eating vegetables. So children, that's our unit of analysis. Do they grow more quickly if? Okay, so we can see that very clearly by the way that statement is worded, that growth is the dependent variable. What is that conditional upon regarding the statement? Eating vegetables. So those are our three concepts. Children, the unit of analysis, growth, the dependent variable, and vegetables, the primary independent vegetable, the primary independent variable of the study. My goodness. So how do we operationalize those things? Well, children, we have to be specific what we're talking about here. Is there a specific age range that we're talking about? Where do we draw that cutoff line between, being a child or being a teenager or being an adult? We have to be specific. Are we talking about a specific country? Are we talking about different race or gender attributes of children that is theoretically important? What about growth? What do we mean by growth? Are we talking about the weight of a child, their height, maybe mental growth? How are we going to measure growth? And then finally, vegetables. What do we mean by vegetables? Are we using the Ronald Reagan definition that ketchup is a vegetable? What type of vegetables? How much vegetables need to be consumed to have an impact on growth, right? So these are all things that the data scientist has to think about. Okay, one more example. Now, with the shameless promotion of my best boy Archie on his 4th birthday, are dogs who are walked more frequently also healthier? Well, first, what are the concepts? We've got dogs, we've got exercise, walking dogs more frequently, and then we've also got health, the concept of health. So dogs are the unit of analysis by which all observations will be measured on that entity, that level for dogs. We've got exercise, which is the primary independent variable here. Does exercise have an impact on health, the dependent variable? Well, how do we measure these things? First of all, what kind of dogs are we talking about? Is there a specific breed or type or age that we're going to study in our analysis? What do we mean by exercise? Does that mean that there's a specific duration of exercise, an hour, 2 hours a day? Distance, does that matter? Does the climate or region need to be taken into account? And then finally, what do we mean by health? Are they more likely to get sick? Are they more likely to live longer? So all of these concepts have to be painstakingly thought about and discussed in the research paper, because you want to have a very specific research question with very clear operational terms. Finally, you can see after years of doing this type of research, you can ultimately get to the point where you're having to operationalize very complex or abstract concepts that require a lot more data collection and analysis. So perhaps we had the research question, do Supreme Court judges make decisions based on their own political attitudes or by the law? And this is a very common research question in political science, but it's very difficult to answer. So first, our unit of analysis is Supreme Court judges. What we're really interested in are the decisions that they make. That's the dependent variable. And here the statement is arguing that perhaps political attitudes of the judges, that has some impact on the dependent variable, which is court decisions. So how do we operationalize these things? Well, we're talking about the Supreme Court, those judges, that's our unit of analysis. Which judges are we going to examine? Is there a specific time period? How do you justify that time period? Court decisions. Well, obviously the court makes decisions on lots of different issues. Do we think that political attitudes might be more likely to affect decisions in a specific domain area like property, federalism, civil rights, and political attitudes? How do we measure the political attitudes or political predispositions of a judge? Do we look at all of the cases in their history and whether they tend to make a liberal or conservative decision? What does that even mean? Do we look at the party of the president who appointed the judge and make an inference there? So you can see how really complicated operationalization can become depending on the complexity of the question itself. Next, I want to talk about making sure that our measurements are accurate. And there's really two closely related terms that I want to explore in this lecture to help us determine whether or not we have good measurements, whether we have good operationalizations of our concepts. So the first is reliability. So here we're talking about determining whether or not the measurements are reliable. Are they consistent across our cases? And the second is validity. Are our measures valid? Do they accurately reflect the concept we are trying to measure? So just remember, reliability means that our measures are consistent, and validity means that they are accurate. So let's take a deep dive into reliability. So let's say that Dwayne Johnson wants to know his weight. He steps on a scale 3 times and it reads the following weights each time: 260 pounds, 300 pounds, and 180 pounds. So the first thing that we have to ask ourselves is that a reliable measurement? Is it consistent? Obviously, it's not consistent at all. It ranges anywhere from 180 pounds to 300 pounds. Those are very inconsistent measurements. Let's say he buys a new scale and he gets the following 3 results each time he steps on: 230, 225, and then 230 again. Are those measurements reliable? Well, comparatively speaking, yes. Those measurements are clustered together. There's much less variance between the measurements, so we would say that the second scale is far more reliable than the first scale. Let's take another example of reliability that's more a political science example. So say that we wanted to gauge support for the president among college students. And we have 3 different samples. So say we've got sample 1 that comes from one university, sample 2 is students at a different university, and sample 3 are students at a third university. So everybody gets asked the same questions. Question 1, do you support the job the president is doing? So for the first sample, we see a 50-50 split. In sample 2, we see that 52% said yes, they support the president, 48% said no. And then our third and final sample, we see 48% said yes, and 52% said no. So when we look at all of the responses from all of our different samples across the board, would you say that question 1 is reliable? Well, it seems to be so, right? These are pretty consistent. We see that support ranges from about 48 to 52% in support for the president. So that seems pretty consistent. Let's say we had a second question on there that also wanted to gauge support for the president. And question 2 reads, considering the president does not support a minimum wage increase, do you support the president? And when we look at how respondents answered this question across all 3 of our different samples, we see nowhere near the same reliability or consistency from the previous measure. So question 2 for sample 1 has now changed to 70% do not support the president, 30% do. When we look at sample 2, we see that support radically increases from the previous one. So 90% yes in this sample, 10% no. And then in our final sample, 62% report supporting the president compared to 38%. So what all of this tells us is that question 2 is not a reliable measure. It's highly inconsistent across all of our samples. So while it may be valid, a valid question, a valid attempt to gauge or measure support for the president, it's highly unreliable. So here's a few quick notes on what you can do to make sure that your measures are reliable. So first, make sure that all the measurements are consistent. Now, reliability is mainly a concern for repeated measure survey methodologies. The one way that we determine that the measurements are in fact inconsistent is because we're comparing measurements at one point in time to another point in time. But they are nonetheless very critical concerns for the research process. So say you were measuring intelligence among respondents for each week. We know that people who are intelligent today will be intelligent next week and the week after that. So if our measures are fluctuating significantly or they're very inconsistent week to week to week, we would have to consider that as perhaps not a very reliable measure. And one of the things that can be a little complicated about reliability and validity is that if, in this case, it's not reliable, this measure for intelligence, probably because it's not measuring what it's intending to measure. It seems like it's measuring something else, so it's not reliable and it's probably not valid either. Second, something that's generally a little bit more applicable to people who are beginning out in the research process is that we have to consider reliability in content analyses. So let's say that we were interested in examining are liberal or conservative newspapers more critical of the government. Well, we would have to make sure that our bias was not influencing how we evaluated that content in the first place. So if you are a conservative and you are reading liberal accounts of the government, you might unintentionally evaluate those sources a little bit more critically because you disagree with them, right? These are just kind of some inherent biases that can occur when we're doing content analyses. So one thing that people generally do to avoid such bias is get a lot of people to evaluate different sources and then kind of average those scores together for an overall, liberal or conservative estimation, or, is this source really critical or is it not critical of the government? So those are just some things that researchers generally do to account for reliability bias and content analyses. And then a third example, let's say that we wanted to assess school funding based upon test scores. One thing that you have to consider is the generalizability of the thing that you're studying. So for instance, and these are all completely made up, they're not real at all, but let's assume that if students score higher on the FSAP, the standardized test, totally made up standardized test, that the school will receive more money from the federal government. And this is generally pretty common, right? Schools score really high on standardized tests, they get more federal funding. But let's say that, before we embarked on this research process, perhaps we did not know this, only 20% of schools in the United States actually use the FSAP, while 80% of schools use the NTAP. I don't know where these ridiculous letters came from. So what you can start to imagine here is that using the FSAP, that would not be a really reliable operationalization of student performance because that's not really generalizable. A much more reliable, consistent measurement would be using something that applies to all of your cases. So in this case, the NTAP standardized exams, okay? So just like we discussed, validity is all about accuracy. So now let's kind of shift the focus to validity. How do we know if the measures accurately reflect the concept that you're trying to study? So I'm going to show you this picture of this correlation matrix. I know it might be a little bit intimidating, but don't worry, the information itself is not, or the calculations, I guess, are not necessarily important at this point. We will learn how to do this eventually, but I'm going to walk you through kind of this graph and the importance of validity. Your book goes into a lot of depth on different types of reliability and validity, and I'm not necessarily concerned that you know the difference between construct validity or convergent validity or discriminant construct validity. I simply want you to know the differences between reliability and validity just on their own. So let's take a look at how we might assess validity in this hypothetical data here. Say that we are interested in developing a measure of liberalism. So we want to understand how attitudes about certain policies might give us greater insight onto why someone is very liberal, somewhat liberal, or not liberal at all. So what you're looking at here is something we call the correlation matrix. It helps us understand how related concepts are to one another, how related variables are to each other. And these things that you see here are correlation coefficients, these numbers here. A correlation coefficient can range anywhere from -1 to +1. And what's important to remember here is that values closer to +1 tell us that there's a strong positive relationship between those two things. Scores at 0 or around 0 tell us that there is no statistical relationship between the variables, and scores closer to -1 tell us that there is a strong negative relationship between those two things. And again, we'll discuss how to calculate correlation coefficients in much more detail later, but what I really want you to focus on now for this example are the scores that are closer to 0, which again suggests that there is a minimal to no relationship between those two variables. So we expect that attitudes on these questions will help us determine a scale of how liberal a person might be. And if we look through the chart here, we see evidence of some pretty strong positive relationships. There seems to be a strong positive relationship between attitudes about welfare and abortion, welfare and Social Security, welfare and affirmative action, and the income tax. If we shift to another variable, military spending, we can see that that's strongly correlated with most of the other variables as well, and so on and so on. These numbers are pretty high and they're pretty positive. So it looks like there's strong positive relationships here between all of these variables. However, we have these two indicators down here that have scores very close to 0. And this tells us that attitudes about school vouchers are not really related to attitudes about any of these policy questions, and the same is true for attitudes about the rights of the accused. The correlation coefficients here are very small, and that signals to us that attitudes about school voucher programs and attitudes about the rights of the criminally accused, they don't really seem to be related or correlated to any of these other policy questions. So as the researcher, we would have to make the determination that these two questions don't seem to be very good indicators of how liberal a person might be, because they're not correlated with any of the other policy objectives. So in other words, these measures do not accurately measure how politically liberal a person might be. They're not valid. They don't accurately measure the concept. And so as the researcher, you might have to make the decision to not include these variables in your analysis. Thinking of validity another way, imagine we wanted to ask people to report their favorite color, and these were the options that were given. And we would reliably get different people selecting different colors, but these results would not be valid because they don't accurately reflect the concept being studied, which is color. All of these are just different shades of blue, and in no way reflect the total spectrum of color, which is the thing that's being studied. Another helpful way for thinking about the differences between reliability and validity is like shooting arrows at a target. So let's say that we have 3 different archers shooting targets, and we want to determine how reliable and valid their shooting skills are. So let's look at the first target. The first archer is highly reliable, meaning that he's very consistent. So when all of the arrows are grouped together like this, that means that he's a very reliable shot. But he fails to hit the bullseye, meaning that he's not very accurate. So in other words, he's very reliable, but his shots aren't very valid. The second archer generally hits the bullseye, or at least comes close, so he's pretty accurate, but his shots aren't consistent. They're all over the target. So here, they're just not very reliable. So we could summarize this by saying, is somewhat accurate shot, but not very reliable. And then finally, the third archer is highly consistent and highly accurate. All of the shots are grouped together, and they accurately hit the center of the target. So the way that we measure our research concepts should similarly strive to be the third archer, highly reliable and highly accurate. So let's just run through 3 quick examples to look at a statement and try to identify whether it's reliable and also valid. First, a researcher asks respondents to evaluate a new tax plan after telling them the plan will increase their taxes by 75%. Well, we can imagine that telling people that the tax plan is going to significantly increase their taxes, that's going to produce a pretty unfavorable response. And you can imagine that if we just asked people to evaluate a tax plan without this little frame that we've put around the statement, that responses there might vary much differently than telling people it's going to increase their taxes. So we could kind of assume or gather that the way of measuring this question is not really reliable, but it is somewhat valid. It is measuring the thing it's intending to measure, which is evaluations on a tax plan. Generally speaking, if something's not reliable, if a measure is not reliable, it's not consistent, that generally means that it is also not valid. But there are some cases in which we could conceptualize a measurement to be not reliable, but valid. It's a little tricky, but for this was kind of just to illustrate the example, but in most cases, if a measurement is not reliable, it is almost certainly not valid as well. Let's go to another example. Let's say a researcher collects the GPA scores of every student to measure the happiness of students on campus. Well, this method, this approach to measuring what's the dependent variable, which is happiness of students, right? The thing that we're trying to explain. This is a reliable measurement, measuring GPA scores, right? That's going to be different for every student. That's going to be a consistent measurement that you have for every single student, but it's not a valid measurement of happiness because GPA scores have nothing to do with happiness. So you've decided to measure a concept, happiness, with an unrelated term, which is GPA scores. So that's not a valid measurement to use. Finally, a manager collects data on the number of reports processed by each employee to measure employees' productivity. Well, this sounds pretty good, right? We've got a concept, productivity. How do we measure that? Well, maybe the volume of work that they produce. Okay, we have data on reports processed by each employee. So this is a really good approach to operationalizing productivity. Now, I know that these can be a little tricky to wrap your head around, but we will do lots of in-class examples on the difference between reliability and validity and demonstrate how in some cases something can be reliable but not valid, or how something can be valid but not necessarily reliable. And as always, if you have any questions, particularly on this topic, just be sure to post those in the discussion board.